Hello everyone, welcome back to the channel. Today we are starting with the second topic, or you can say second subtopic of this permutation combination, that is permutation. In the last video, we have learned the basic difference between permutation and combination. Today we are going to focus on the permutation, and in the next video we are going to do the combinations, right? So let's start with the permutation. As we have already seen in the last video, what exactly is permutation? When we said that there are four batsmen, and you have to pick three. Their batting orders matters. Batting order matter means B1 coming first, then B2, then B3, and B1 or B3 or B2. These are the two different scenarios. Why? Because first batsman B1 is coming first, then B2, then B3. But in the second case, B1 is coming first, B3 is coming second, and B2 is coming last. So permutation in the case when there are n objects or n people to choose from, and we have to pick r objects. So that is n p r. Like we have seen in the example of batsman, that is n divided by n minus r. This is what we have learned in the last video. I hope this is clear. Very basic. Let's move on to the next one. Now they've asked you, there are four foreign players. You have to pick all four of them. You have to pick all four of them, but still their batting order matters, right? Batting order matters. So why? So B1 will be the first batsman, B2, B3, B4, that is the first case. Then B1, B2, B4, B3 is the second case. Still B1 is coming first, but now B3 is coming next, B2, B4, then B1 is first, still first, B3, B4, B2, and so on. I hope this is clear. So their batting order matters. Otherwise, there are only four players are we are choosing. This would have been only one case. Means we have four players. We have just told them just come with us. So that is only one way of picking four people out of four. But if their batting order matters, so then the term is NPN, that is n factorial divided by n minus n, that is 0 factorial. So that is n ways, factorial n. So number of permutation of picking n objects out of n objects is factorial n. How? Because that is NPN, right? I hope this is clear. Now moving on. Number of way in which six people can sit in a four-seater car. Now, again, this is very similar to the batsman example. Total players we have is six and four-seater car. Now, does their sitting arrangement matters? Yes, because there are four seats in the car. This is driver seat. This is front seat. This is back seat number one. Back seat number two. So, if A is sitting here, B is sitting here, C is sitting here, and D is sitting here, and other case is now B is sitting in the driver seat, A is sitting next to him, D is still sitting here, C is still sitting here. Even though we only have four people who are sitting in the car, A, B, C, and D, but their sitting arrangement different. So that is why in such a case we use the formula of permutation. Why? Because their sitting arrangement matters. So we have 6C 4, that is, oh, not 6C, again mistake is 6, not 6C. When the sitting arrangement matters, we P. So 6 divided by 6 minus 4. You can solve it, you will get the answer, right? Now, number of ways in which two people have to choose for two-seater. So means there are two people, A and B. You have to pick both of them. You ask them to come with us. So we have N is 2, R is 2. So N P R is 2P2, that is 2 factorial divided by 2 minus 2, 0. So you have 2 factorial, that is 2. So there are two ways. How come two ways? So if there is a bike with you, this is a bike with you. So A is sitting in the front, B is sitting in the behind. Or other way is, this is a bike with you, A is sitting in the back, B is sitting in the front. So when the sitting arrangement matters, so there are two ways of picking two people out of two people. So in the this is the example of factorial n, means npn. I hope this is clear. Now we have learned till now the basic permutation. Now let's move on. Now suppose we have suppose we have 10 balls. 10 balls means there are 3 black balls, 4 green balls, and 2 red balls, and 1 yellow ball. So you have 3 blue balls, 4 green balls, 2 red, and 1 yellow. So there are total n balls. So you have to pick n objects. N objects means you have to pick 10 balls. You have to pick 10 balls where 3 are of one kind, 4 are of one kind, 2 are of one kind, and y is of different kind, right? So what you are going to do in the case of their permutation in this case is factorial 10 divided by factorial, how many first kind are similar? 3. Factorial green. Green, how many types of green are there? 4. Red is 2. Yellow is 1. I hope this is clear. So factorial n means we are picking 10 balls out of 10 balls, but since they are different, since they are of the same kind, so this b1, b2, b3, right? b1, b2, b3, these balls are not different, they are the same. So in this case, the formula is factorial n divided by factorial p, means p of one kind, q of second kind, r of third kind. So this is the formula for permutation in this case. We'll see an example on it. You will understand even more, right? Now let's see. If the word is given to you, B letter is given to you, A is given to you, N is given to you, K is given to you. They ask you to make how many letters? 4-letter word. 4-letter word can you make? How many 4-letter word can you make? So how many 4-letter word you can make? So first one you can make is B A N K, or you can make A B N K, A B N K. You can make also N A B K, and so on. So you have to pick out of N4. You have to pick 4 letters, right? 4. And does the arrangement of them matters? Very much, because B A N K and B N A K are not the same thing. B A N K and B N A K, even though we are choosing only 4 letters, these two are very much different. So the arrangement of the letter matter. So in our case, so the permutation is number of ways we can is NP4. So if you solve this, you will get 4 factorial as the answer. So 4, 3, 2 into 1, 4, 3, 12 to the 24. So 24 letters you can make when you are given, you have been given B, A, N, K letters. So 4-letter word you have to make out of 4 letters. So the formula is NPN, means 4P4. Now this is another example. You have to use these letters M, I, S, S, I, S, S, I, P, P, I, Mississippi. Now the formula is still the same. How many letters are there? 2, 2, 4, to 6, to 8, to 10, 1, 11. So total 11 letters are with you. N is 11. How many M we have? We have 1 M. How many I we have? 1, 2, 3, 4. How many S we have? 4. How many P we have? 2. So we have 1 M, 4 I, 4 S, 2 P's. So how many words we can form with this? N factorial. This means 11 factorial divided by how many M are there? 1 factorial. How many I's are there? 4 factorial. How many S are there? 4 factorial. How many P's are there? 2 factorial. And this is the permutation, or the number of ways you can form, or number of words you can form using these letters, right? Where the words are of same kind. I hope this is clear, right? Moving on. Number of words you can form using the letter Mumbai. So this is given to you. M, U, M, B, A, I is given to you. So you have to make a 6-letter word. You have to make a 6-letter word. 1, 2, 3, 4, 5, 6. And they have said that first word is you, last word is I. So you and I are gone. How many letters you have to fill? You have to make four. You have to fill four letters. How many letters you have with you? I am left with MMBA. So I have four letters with me. Four letters I have to fill. Four letters are there with me. And how many are of the same kind? M is of two times. B is one time. A is one time. So number of A is 4 factorial, and that is n factorial, divided by 2 factorial, 1 factorial, 1 factorial, because m is a 2 type. M is means m is repeating 2 times, b is repeating 1 time, a is repeating 1 time. So 4 factorial divided by 2 factorial divided by 1 factorial and 1 factorial. I hope this is clear. Here we are fixing you and I. You cannot do anything about these two. You can only fill these four cells, right? I hope this is clear. Now moving on. There's another word. This is California, where C and R are at the start and the end. C and R. So first thing, I'm just going to fix C and R, right? So how many letters I have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10 letters, 2 are gone. And how many letters I left with? 8 letters. So I have to fill 8 letters, right? I have 8 letters with me, right? Now, C and R are gone. So I am left with A, L, I, F, O, N, I, A. I hope this is clear. Now, how many A's I have? A I have is 2. How many L I have? I have 1. I have is 2. F is 1. O is 1. And N is 1. I hope this is clear. A is 2. L is 1. I is 1. F is 1. O is 1. N is 1. How many letters? 8 divided by 2 factorial for A, 1 factorial for L, I is 2 factorial, F is 1 factorial, O is 1 factorial, N is 1 factorial. So I'm just skipping them. So the answer is 8 factorial divided by 2 factorial divided by 2 factorial. I hope this is clear. So C and R are fixed. You don't have to use all the 10 letters. You just have to use 8 letters. I hope this is clear. Now, next part is find the number of words which can be formed using letters of California without using R and N. So I have CAIL Fornia. So now they have said I cannot. So I don't have R and N with me. So what I'm left with? I'm left with CALIFOIA. So these are the letters 2 to 4 to 6 to 8. So I'm left with 8 letters. So how many letter word I can form? I can form 8 letter word using the remaining letters, right? So C is repeating how many times? 1 time. A is repeating 2 times. L is repeating 1 time. I is repeating how many times? 2 times. F is repeating 1 time. O is repeating 1 time. I hope this is clear. So the answer is 8 factorial divided by 2 factorial divided by 2 factorial, same as the last question which we have seen in the last slide. I hope this is clear. Permutation, basic of permutation. Now moving on. Basic permutation is done. Now we are going to move to circular permutation. Now circular permutation, here you have to understand, I'm just moving to these slides, and I have to make you clear what's the difference between clockwise and the anti-clockwise, right? So we will understand what does the anti-clockwise and clockwise mean. So let's see. Suppose there is a table. Here there are 4 seats. Seat number 1, seat number 2, seat number 3, seat number 4. And seat is marked as, this is seat number 1, seat number 2, seat number 3, seat number 4. Now, seat number 1, seat number 2, seat number 3 and seat number 4 have been marked, or they have been marked. Now 4 people come in this function. A is sitting here, B is sitting here, C is sitting here, D is sitting here, right? A is sitting here, B is sitting in the seat number 2, C is sitting in seat number 3, and D is sitting in the seat number 4. Now let's take another example. This is seat number 3, seat number 4. Again, I'm marking it as 1, 2, 3, 4. Now, if you just move A to next position, A is sitting here, B is sitting here, C is sitting here, D is sitting here. Now, if I tell you, is both of them equal or not? No. Why? Because in seat number 1, A was sitting earlier. Now, D is sitting in seat number 1. Seat number 2, B is sitting, A is sitting now. Now, if you see, their sitting pattern is the same. A, B, C, D. Means A is sitting in the first position, B is sitting in the second position, C is sitting in the third position, D is sitting in the fourth position. But if you see here, if I tell you what is the seat number, this what I've done, I've just A B C D is a pattern here, A B C D is the pattern here, sitting pattern here. But because the seat number have been marked, these two are not the same, right? These two are not the same. I hope you understand. These two are not the same. When the sitting the when the sitting have been marked, these two are not the same, right? So this A B C D, right? And if I read it so anti-clockwise and clockwise, or when the seat number, suppose seat number or the sitting arrangement is given to you, then these two cases are not the same. Now let's see. If I just remove this, these seat number have been removed. Now is two cases same? Very much. Why? Because A is sitting next to B, is sitting next to C, is sitting next to D, and D is sitting next to A. This is the same in case number B. So when seating arrangement is not given to you, or seat number are not marked, then both cases are the same. But when seating arrangement or seats have been marked, when both cases are not the same, right? Now let's see. If four people are sitting around the table, ABCD is known as ADCB, but ABCD. So ABCD is not same as ADCB. Why? Because their seats have been marked. Since their seats have been marked, these two cases are not the same, right? ABCD means simply telling you that seats have been marked. So that is why if your reading says ABCD, that is known as ADCB, or you can also say ABCD is not equal mean it does not mean BCDA, does not mean CDAB, and so on, right? So their sitting arrangement matters, or seats have been marked. So in this case, how many ways you can make four people sit? Four people are there. You have to make them sit around in a table when their seats have been marked. So the number of A is factorial n minus 1. So if in our case that is 4, so the 4 is 4 minus 1, 3. So 3 factorial. 3 into 2 means 6 ways, right? What are the 6 ways? A, B, C, D sitting, then A, B, D, C, then A, then what else? A, C, B, D, then A, C, D, B, then and so on. A, then what else? A, A, C, A, D, B, C, and A, D, C, B. These are the 6 ways. Now, A, B, C, D, A, B, C, D, and what else? A, B, C, D, and there should be some other case. D. So these are the only 6 cases which are possible, right? So n minus 1 factorial, right? Now moving on. If their seats are not marked, A, B, C, D is equal to B, C, D, A is equal to C, D, A, B equal to so on. In that case, our formula is factorial n minus 1 just divided by 2. I hope this is clear. In the last part, we have factorial n minus 1. Here we have factorial n minus 1 divided by 2. Just remember the formulas. When the sitting have been here, the seats are marked. Seats are marked. Here, not marked. I hope the things are clear. When we'll do PYQs, this will get even more clearer. And I have not seen any question on circular permutation. So you just have to remember what the basic formula is. If any question comes, you will be able to solve it. Right? Now moving on. If clockwise and anti-clockwise are different, means seats are marked. Seats are marked. Right? Like the case number 1. Number of now, what did in the last example we were choosing n people out of n people. We have 4 people and we have to make them sit in a circle or 4 seats. Now you have n people and you have to pick r people out of them to make them sit in r seats. So the formula is now, in that case, the formula becomes npr divided by r. This is the formula when you are choosing r people out of n people. Here, in this case, we have n people and we are choosing all n, everyone. Here, we have n people and we are choosing only r people. So, npr divided by r. Here, anti-clockwise and the clockwise are the same, means seats are not marked. When seats are not marked, the formula is we are choosing r people out of n people. So npr divided by r, just like this last example, and also 2. So npr divided by r divided by 2. I hope this is clear. Now, let's take 2 example and that will complete our circular permutation as well. Now, number of ways you choosing 3 beads out of 6 beads. So, there's a ring and there are 3 beads. 1, 2 and 3. N is equal to 6 and R is 3. Now, are beads identical? Yes. 3 beads which you are choosing, they are same. This is same, same, same. Same means does not matter, since this is the ring. This bead or this bead or this bead, the position does not matter. Look at your ring. Suppose there are 3 stones on a ring, right? One here, and one here. Does it matter to you which position the stone is taking? No. If we call it position number 1, 2 or 3, we can also call this position as 1, 2 or 3, right? So their position does not matter. So this means seats are not marked. When the seats are not marked, the formula is npr divided by r into 2. So this is a formula you can use 2 in this case, right? Now, number of ways in which 8 people can sit on a circular table. So means we have n people and we are making everyone sit on the table when none arrangement has the same neighbor. None arrangement has the same neighbor means if A, B, C, D are sitting, so this and this are not the same. They don't have the same neighbor. No same neighbor means now the seats are marked. Seats are marked. So A, B, C, D is not equal to A, D, C, and B. Means the right. So the person sitting next to, suppose if this is one case, A, B, C, D, right? None of the same has the same neighbors, right? So A, B, C, D is not equal to, should not be equal to A, D, C, B. So in our case, the formula was n factorial n divided by r. You can go back and see. So factorial n divided by r is the, was this the formula? Let me check. Sorry, this is not the formula. The formula was, there was no r in this case. The formula was factorial n minus 1. If it is so said that ABCD is equal to ADCB, means seats are not marked, we would have said n minus 1 factorial divided by 2. But since they cannot have the same neighbor, so n minus 1 factorial is the answer. So that is 7 factorial. I hope this is clear. Circular permutation, again I am saying, circular permutation, there were no PYQs, so don't put a lot of time on this. You just have to understand the basic and try to apply them if any question comes in the exam. So that's all for this video. Here we have learned the permutation, what NPR is, and also we have seen that NPN is equal to factorial n, and also we have seen that factorial n, they are the total objects where P are of one kind, Q are of second kind, R are of second kind. So the number of ways was n factorial divided by P factorial divided by Q and R factorial. And we have seen the example of Mississippi, right? So that completes our permutation. This is the second class. In the next class, we are going to do combinations, and then we are going to move to the previous year questions. So that's all for this video. Best of luck. And please, if you have any doubt, feel free to post them in the comments.